Tonight's curiosity is accompanied by hired hand brown ale from Heritage Farms Brewing. They describe it as having pronounced flavors of biscuit and caramel along with light notes of toffee and chocolate, all in an English-style brown ale. So the victim of tonight's curiosity teardown is this light switch, but it is not exactly an ordinary light switch. And note there's an LED there and an extra little control switch right there. Feel free to try and look up that model number. I have, and I didn't have any success. What it is an early version of a smart learning light switch. This thing is intended to be connected in series with the light, just like any normal light switch. And it claims to be able to learn your usage pattern when you just manually use it like a normal switch. And then it will repeat that pattern when you set it into motion. So it can act kind of like security lights, turning on and off lights in your normal pattern. Or at least that's what it claims. I used it for a few years back in the late 90s when I first bought it, and it always seemed pretty random. It did turn lights on and off, but it didn't turn them on and off to match the pattern that I had set. So I don't know. I used it for a while and then stopped using it. So let's connect it up. It says it is only to be used with incandescent lights. It repeats it in French because Canada. 120 volts AC, maximum 400 watts. I also tried searching on CSA's website to try and find any more information, but I could not get anything more on this. So let's just hook it up and see if we can make it do anything interesting. It's been, as I said, years and years since I had this thing in service. I just found it when I was doing some more cleaning up around here, and I figured I'd take a look at it before I toss it into the electronics recycling. We need an incandescent light bulb. Incandescent light bulbs are getting harder and harder to find. I do have this 15-watt little bulb, so let's screw that in and see if it does the job for us here. Turn on the power bar and turn this guy on. Oh my! You may think it's flickering on the camera. It's flickering even worse in real life. That's not good. Let's see what else I got around here. The only other incandescent that I can find is this black light bulb, which is a 75-watt bulb. Maybe that thing just isn't creating enough current draw, which seems weird. I'm not entirely sure how this thing works. It has to be drawing a little bit of current through the bulb when the bulb is idle, otherwise it wouldn't have a way of powering itself. Let's see what that does. Okay, well that comes on and it's not flickering and flashing. Okay. Fine. I think if you remember, yeah, you push and hold. That turns on the little LED in there to indicate that it's in automatic mode. So theoretically, if I waited 24 hours, it would turn this bulb back on for a short period of time. Obviously, we're not going to wait that long because our intention here is to tear this thing apart. But I just do want to try it with a few other types of bulbs, like this old compact fluorescent, and see what it does. Oh! Can you see that flickering? That's what it turned off. Let's see what happens when we turn... Okay. So I'm guessing the reason it's flickering there when it's even shut off is, again, this thing is drawing a little bit of current through there to power itself. So that's obviously why they said not to use that. Let's try an LED. This is a Philips, what are we here? 8-watt. Let's see what that does. Oh, we don't get any flickering when it's off. Oof. And it does turn on and it's not flickering. So it does seem to be compatible with that. All right. Let's try it with one of these. Now this one has just a basic capacitive dropper in it. That one probably has a much more complex power supply. So yeah, again, with this turned off, that is glowing and it doesn't actually do anything. So it's drawing enough current through there that it's turning it on. So yeah, that's interesting, but that's not why we're here. So let's just disconnect this and get this other junk out of the way, and we'll take a look inside here and see what makes it tick. Somehow I lost some footage. I lost the footage of me popping these 6 little tabs open and pulling this thing apart. At which point I found a circuit board. I found this metal piece, which is the wall plate. It was riveted onto this heat sink, there and there and there, those 3 rivets. This rivet also goes through the tab of this device here, which I will explain in a minute. So pick up now where I go and drill out these rivets, and then we continue the video. There, one quick rivet delete, and hopefully that should come off there. Oh, damn it, hang on. That rivet is also... Arr! Right, maybe this time it'll come apart. Come on, you. There. Well, I suppose I could have desoldered that device. That would have been just as quick. But no, I'll do it that way. Anyway, let's see what we got on here. So, oh, oops, I abused that a little bit too much. Okay, well, what is that device, I guess? BTA 12 or 600 SW.
It's a triac. All right. I guess that makes sense. That would be what's switching the load. Sure. It looks like it should be able to handle about 12 amps, which is way more than this unit is rated for. So, okay, sure.
Well, clearly this is not going back together. Not that I intended it to. So let's see what else we have. A little tactile button in the middle there. A couple of resistors there, an electrolytic. Good size capacitor, which I would expect to be for capacitive dropper. MF684K. 684 according to my handy dandy little cheat sheet, because I don't know why I've never been able to memorize capacitor labeling. But anyway, it is 680 nanofarad, which seems like a reasonable value for a capacitive dropper. A handful of diodes. There are 2 regular diodes. Well, there is a rectifier type diode. That's more of a signal diode. Then there are 2 diodes labeled Z1 and Z2, which are presumably Zener diodes. LED down there. Electrolytic capacitor, 100 microfarads at how many volts? 100 microfarads at 16 volts. Okay, so that will be on the low voltage supply of the power supply, which is supplying power to this little Motorola chip here. MC68HC705J2.
Low-cost, high-performance family of 8-bit microcontrollers. Sure. It has 2K of EEPROM, 112K of RAM, and a bit of bootloader ROM in it. 14 bidirectional GPIO, 15-bit timer, all in a 20-pin package. And it is probably way overkill for this application, but I expect that low-cost bit won out.
And then there is one other device on here which looks a lot like a transistor, and it is connected to one pin of that LED, so that makes me think that it is even more likely to be just a plain old transistor. MC341, etc. Don't know that one. Let's look it up. Could not find a data sheet for any of the numbers that I found on there. However, it is just your basic PNP transistor. Nothing too special about it. And as I said, it was switching the LED on and off, and presumably if I follow the traces back far enough, we'll get back to one of the GPIO pins on this microcontroller, and it will be doing all the magic. And about the only other thing is we have this little battery on here, which is a 3.6 volt, 30 milliamp hour. So my guess is that that is to keep the microcontroller running in the event of a power outage or something like that. So now, let's figure out how this thing derives its power supply. Like I said, presumably it is drawing a little bit of current through the light bulb, and So then how does it not short out its power supply when you turn that on, unless there's a bit of a series drop? And remember with, which one? With this little guy here, it was flickering even when it was turned on. I'll have to think about this. But I guess this means that I'm going to have to at least partially reverse engineer this thing. Obviously, with the chip there, I won't be able to dive too deeply into it, but I should hopefully be able to get a reasonable schematic out of this. Give me a few minutes and I'll see what I can come up with. Well, that took a little bit longer than I thought, but I think I've got most of it. I left out a couple of little bits that are just like, what are they? Actually, I think I did get everything. I hope. Probably. Maybe. We'll see. So, to the best of my knowledge, and as far as I can tell, the AC comes in here. There is a switch there, which is this little slide switch, which doesn't have a label on it. But that is the one which is this little switch here at the bottom. So that just completely disables the entire thing. After that, it just goes directly to the two main terminals of the triac, which means when this thing is powered on and powering something on, it shorts out the rest of the circuit and it has to run on its battery. So that's interesting, which means, I guess, if the battery drops out, then the triac will drop out and the light will go off and it'll start recharging again. Anyway, on the switch side, it just goes to the VDD, the plus voltage of the overall circuit, including the plus side of the battery, pin 9, the plus voltage pin of the IC, and a few other places. The other side of the AC goes through a 180 ohm resistor, not a huge value resistor, then through that big 680 nanofarad capacitor, this one, which is acting as a capacitive dropper, and then a zener across it. So everything on this side is now clamped to the 3.2 volts of that zener, approximately, or maybe a little bit higher, because this rectifier diode, 1N1004 standard old rectifier diode, where are you? This one here is going to drop 0.7 or so. Then we have smoothing on that electrolytic capacitor, then the battery, and then we just go off to various different things. For instance, there's a pull-up resistor on the little tactile switch, which is the one that is operated when you push this. And that goes to pin 8 of the microcontroller. What else we got down here? Pin 10 VSS comes off here. Then that transistor, I thought that it was driving the LED. It's not. Oh, that's what I didn't draw on here at the LED. It is apparently connected to the reset pin of the chip there, and it is also going to pin 7 of the chip, so presumably there's an output on pin 7. And other than that, this is just the reset circuit, weirdly. Other places, there's this zener and this 33K resistor measuring, I'm guessing for zero crossing. It's picking it up off the AC there, and that's going out to pin 3. There is a crystal. This chip isn't using its internal, even if it has an internal oscillator. So there's a crystal with a couple of loading capacitors as usual, going up to going to the ground. Negative, sorry, don't call it ground in here because there isn't really a ground, and that's just going to pin 1 and pin 2. There's the pin out of the chip. Pin 1 and 2 are the oscillators. 3 to 8 are GPIO. There's 8, where pin 3 is used there. Pin 7 is used there. VDD and VSS are on pins 9 and 10, so that's the positive and negative voltage. 11 through 18 are more GPIOs, and I don't think those ones are being used on here. Let me just look at my ugly version of this drawing. Where is the LED? There it is. Oh, it's coming off pin 16. Okay. But I didn't draw that on here just for clarity, so that's using one of those. And then pin 19 is an IRQ, which is not being used. It is being held high. And pin 20 is the reset, which is being controlled by this little guy here. and everything else in it is code, which of course is a complete black box. Neat little thing. I am a little bit confused by, well, I guess it makes sense that it's not stealing power when this is shorted out, when these two wires are shorted out. So it has to run off the internal battery, which is, what did I say it was? 30 milliamp hour. So it won't run forever, but I guess if this only draws a couple of milliamps, then it'll keep a light turned on for, maybe 15 or 30 hours. I don't know, something like that. I don't remember, because I don't remember leaving this on for extended periods of time. And of course, when the triac is turned off, then that can recharge. Don't know if there's much else to say about this. It's an odd little circuit, and I was never impressed with this thing in service. I'm guessing that it runs just a pseudo real-time clock, not even real-time clock, just off the internal clock there. And it never claimed to be 100% accurate, and it claimed that it varied its on and off times pseudo-randomly just to make it look less patterning. And I'm thinking what really is happening is it's just the clock isn't perfect in there, so it's just running and turning your lights on and off based on your previous pattern approximately. Anyway, that was an interesting thing to take apart. It took far longer than I thought to reverse engineer this, because traces disappear under the battery, there's traces disappear under the chip. I had to beep them all out with my ohm meter, and yeah, that took some time. Plus, I somewhat destroyed a few components taking them off, but that's whatever it is, because I didn't want this thing to go back together anyways. Well, thanks for watching. I appreciate that. Questions and comments down below. If you've used one of these before, I'd be interested in hearing your experience with it, because like I said, I wasn't overly impressed with it. It sort of worked. It did turn the lights on and off in roughly a pattern for a while anyway. I'm going to guess that as the battery deteriorated, it's why it probably stopped working the way I expected it to. Anyway, yeah, that was kind of fun. Thanks for watching. I said that already. Questions or comments down below. I'll talk to you later.